Hi, I'm Mr. Huff, and we've had some challenges with Zoom this evening, so I wanted to put together a quick video going through our programs and let you know a little bit about what we have going on over here. I am Marcus Huff, and I teach engineering at the Mile. And this is my classroom space. We have a design studio, maker space area. The students get to move furniture around to meet their needs. And I try to provide enough tools and space and direction so that they can make their own designs and their visions come to life. We also have a computer lab that has some very hefty Windows computers so that they can do CAD modeling. And the most demanding software we use is Revit for civil engineering and architecture. So real quickly, the three programs we offer are civil engineering and architecture. We also offer aerospace engineering. And then for seniors only, we offer practicum and STEM. And this is found, all of these programs are through Project Lead the Way. It's a national curriculum. The practicum in STEM under Project Lead the Way is called Engineering, Design, and Development. So let's go on from there. Let's talk a little bit about civil engineering and architecture. So in my classes, I try to put the students in the position of having to make design decisions and see how it goes over and over and over. That's really my goal for them. I want it to feel like they're in control of those decisions, and then they see if it works great or if it doesn't, and either way they learn. So in this course, we spend a lot of time in some industrial software called Revit, and you can see right here some of the examples. You can do technical drawings and floor plans. We can design exteriors of buildings and landscape and sites, and we can also do interior design as well. So this course kind of focuses on two big projects. We have the first semester a residential design project, so they will design a house for a family, and then they have to go through the same decisions that architects make, and they also have to pay attention to the same code that architects have to pay attention to. The second semester, we focus on commercial design. So I will give them a structure, and they have to come up with a use for it and design the interior and the exterior, including like parking spaces and concrete on the site. We'll also look at some of the things that commercial structural engineers would look at, like how the forces are distributed through the framework and also like runoff on the site and that sort of thing. We also, other than the computer stuff, we also do a couple of hands-on labs. We'll do things like soil analysis, and we'll learn to survey with a transit. So that's a little bit about civil engineering and architecture. This is an example of a floor plan and a rendering that was done from this floor plan right here. It's as if you were standing right here in your design, and you can actually see what it's going to look like. It's kind of fun. This is the project we're working on this year. This is the building shell that they start with, and they have to figure out what kind of business they're going to put in there. All right. Let's talk about aerospace a little bit. This is a lot different kind of class where civil engineering is built on a couple of very large projects. Aerospace is a little bit all over the place. We cover a lot of different ground. We have a lot of different kinds of projects that we do. Again, I want to put students in the position of making design decisions, but we will look at the history of flight a little bit. We'll start learning about control surfaces on airplanes. To help reinforce that, we'll do flight simulation. We will learn about the physics of flight. So like, for instance, in this little graphic here, it's about the coefficient of drag. They'll learn to calculate that and what that number is telling them about the design. We will design gliders. We will design and build and launch rockets. And these are the small model rockets. However, I give them balsa wood and a tube, and we'll 3D print some parts, but they have to come up with the design for it and make sure it's going to work, and then we go launch it and see if it actually works. We'll also touch into some robotics. We use two platforms. This is a VEX system here, and I also introduce Arduino into some of the projects because later as they become seniors going into practicum, I want them to see a microcontroller that they could use in those projects. All right. So this is an example of a glider design project. We start in software and they try lots of different designs there. And it tells them if their design should work or not. It also gives them a lot of measurements and parameters about their design. It gives them a blueprint, and they use that blueprint to go and cut the pieces out of balsa wood and basswood, and then they assemble it, and then we take it and balance it and go test fly it a bunch of times. I have them fly it like 25 times and taking measurements. So then at the end, they'll produce summary statistics and reflect on their design choices. So that's an example of that project. We also have for seniors the Practicum and STEM class. As I said earlier, this is engineering, design, and development. And this is for seniors only. It runs as 2 class periods, and it's one project that they work on all year long. So in this image here, you can see that we have students presenting their design proposals to some people that are going to help them kind of validate, is their design going in the right direction, or do they feel like they're off base? So they do have to periodically get feedback. So kind of an overview of this course. The first semester is about finding the problem and getting, establishing that it really is a problem, and then how have other people solved it, and then how are they planning to solve it. And they go through and they identify what they believe to be the best solution that no one has tried before. And then they design it, and they come up with the materials that they would need to have to build it. Second semester, we get those materials, and they build a working prototype, and they test it. And one of the things I want to see them do is iterate. We tried it. It didn't quite do what we wanted. We made these adjustments. We did it again. And I want to see that process as many times as we can get it done. At the end of this, they're analyzing, does their solution solve the problem? And they will have a lot of testing done with that. So at the end of this, though, they will make a formal presentation, a professional presentation, showcasing how the problem they started with and how they designed a solution to solve it and how effective that solution is. So who is good for engineering? If you've already had an engineering class, then that's great. However, if you are pretty good at math and science, then engineering classes might be something you want to look at if that's something you enjoy. Again, I really do try to focus on project and hands-on stuff as much as possible. If you're good at taking notes about what you're doing and managing your time, that's probably a good fit. So that might be something you want to try.